VLPSos here. This is a video lesson for Python programming, the Pygame module. Pygame is a module that has only recently been distributed with the Python language because it's gained so much popularity. It allows users access to functions to do things with graphics, animation, sound, and keyboard and mouse input. This is an introductory lesson. We're going to do something a little unusual this time. I'm going to immediately scroll down to the Now You portion of the lesson, which usually comes at the end. But this time, we're going to take a look at what the objective would be to practice, because that objective is going to be copying down what is written and saving this file as what we call a stub, a beginning of a program that can be reused for other practice and other programs in the future. So reading the Now You portion, and this is anticipating that we've seen the lesson already, you have seen the bare bones necessary to begin graphics and animation. Most of these lines of code will be a part of every program moving forward. So common, in fact, that it is not necessary to type them every time you begin writing a new program. An incomplete program that you can use to begin a new project is called a stub. Your task is to write what you see here, including the comments, and save it with the title cppg_stub_0.py. So as you can see, this has anticipated that you've seen what we're about to type, but I'm letting you know now so you can follow along and begin typing as you listen and think about the code. Now, you're going to be writing and saving the file that you type, and you're going to be saving it with that name called stub. 0 because we're going to write more versions of stubs as we get more sophisticated code and we learn more. And notice in that title, underscores are used. We want to get in the habit of always using underscores instead of spaces in our file names because we're going to be importing files as resources quite a bit. Let's get started at the top. The first thing that we're going to do is import this new module that we're going to use called Pygame. Import Pygame. And then we're going to do something a little unusual. We're going to run the init function on Pygame. So immediately a line after importing Pygame, pygame.init. And init is a function, so it needs parentheses. Init stands for initialize, and the reason why we need to do this is because Pygame has functions that access the graphics or the screen drivers and the sound drivers in our computer. And all computer systems are different, so that initialization function looks at our operating system, looks at our system specifications, and then sets variables relative to what Pygame is going to need to control the hardware that it sees that it has. So there's the initialization. And we want to define a hello function that does nothing so far, and then get in the habit of bootstrapping that hello function if name double underscore name double underscore is equal to, in quotes, double underscore main double underscore, then run the hello function. And before that, we're going to put a print line to make a note in the interpreter or in idle that we have started the program, and then another print line to end. So we can be sure when our program begins and ends. Now this is already a stub, a very simple one. We're going to save and run, and we should observe that our function does nothing. We see the start and end. We're going to create more space, and then we're going to add some things to our function. I'm going to make a comment in our hello function where we want to get used to putting certain blocks of code. we're going to have a place where we're going to declare our constants, and then booleans. We're going to create a graphics window, so we'll have a section called screen settings. Then an important section called frame loop, so I've capitalized it, and that'll be a good start. In our constants, we're going to declare some variables, one called screen width, and set it equal to 800. We'll be creating a window which we can put graphics and sound and animation and interact with a program in a graphic user interface sense. And it begins with creating the size of the window that we will open. So we're going to have constants to represent those values, the width and the height. And the numbers are integers that represents the pixel size. The screen size then will be a combination of these two, set as a data type that we call tuple, which uses round parentheses. It's similar to a list, but it is immutable. Tuples can contain many things, just like a list can contain many things, but we can't change the size of a tuple or modify its contents once it's been created. So we've created a tuple of 2 because there are 2 things in it. And instead of the square brackets for a list, we're using the rounded parentheses to create this data type called tuple. And that tuple is the variable screen size, a combination of the width and height. We're also going to need a screen mode when we create our graphics window. We'll begin with the screen mode of 0. We'll also need a bit mode, which we can change, but we'll set it at 32 to work well on most systems. And we're going to be counting frames, like the frames of animation. We'll set that equal to 0. So we have prepared many things, but not yet used them. We're going to have a Boolean called running, and set that initial value equal to true. Under the screen settings is where we create the graphics window in this line of code. A graphics window is in the Pygame module under the display set of functions. We use the set mode function, and the set mode function will create the window, but it needs some information in order to communicate to the operating system of our computer to control that window. So what the screen set mode function needs is it needs a size of the window. And we have prepared the screen size and called it screen size to be this information, a tuple of 2, meaning an immutable type that has 2 bits of information, 2 elements in it, the width and the height. So the set mode needs that information. It also needs the mode. We have a variable that we set to be the mode, and the value is 0, as we can see in the value that we assigned to screen mode. Next is a bit mode, and we've used a variable and assigned it to be 32. This information, again, is for the operating system to control what we're creating here, a graphics window. Finally, we're going to have a variable set equal to this graphics window. A very common choice is the variable screen to be a variable whose value is the window itself. So if we want to do things in the window, in the graphics window, then we're going to be doing things to the variable screen. Think of screen as an instance of a graphics window. So screen, the single the single variable is easy to use. It represents the window that we'll be using in the future. Now we're going to run a couple of functions to modify this window a little bit. But we've done quite a bit. Let's see what running our program will achieve if it has indeed created a graphics window. I'm running and I can see that I have a black rectangle that is a Windows window. Notice that it has an X and a minimize and also a generic name for this window, as all operating system windows do. It does nothing else. There's no graphics in here. It's black. Notice that idle is also a part of running this program. Now, if we want to quit this program, it's already ended, but if we want to shut it down, it's natural to click on the X of that graphics window as if we want to get rid of it. But because idle is controlling this window, I ran my program through the interpreter created the window. If I want to exit all of this stuff, I have to X or cancel what's controlling the window. So I'm going to close idle instead of this black rectangle. Now you'll forget that in the future, and you'll probably click the black rectangle window or whatever graphics window you're using trying to shut it down. And your computer might be thrown into it might be frozen and confused for a while until it realizes that what is controlling that needs to be shut down. So save yourself some time and get in the habit of canceling idle in order to cancel both idle and the graphics window. Okay, let's get a little more sophisticated. We're going to run a function from Pygame again, from the display set of functions, the function called set_caption. Instead of Pygame window, we can title the window anything we want, usually the name of our program. If this is a stub, then we're going to title it stub_0, the first in a series of stubs that we'll be using moving forward. Let's do now one other thing. At the very end, we'll go to the frame loop comment, and we're going to start a while loop. We have a Boolean prepared for that. While running is equal to true. Now, a while loop is the backbone of every graphics program because graphics are like a traditional movie, meaning film, made from film and shown through film, as a series of still pictures. And the still pictures that we create, if we cycle through them very fast, give the illusion of motion, just like a film. It's a while loop that we use to compose each still picture, whatever we want to put into that picture, background, sprites, interactivity, buttons that we compress for an interface. Whatever we want our graphics program to be, we compose a still image, like a screenshot, and then that comprises what we call a frame. The while loop then will repeatedly create these still frames. And if we change them slightly every time, then we can create the illusion of motion and the illusion of graphics interactivity. It's the while loop that creates one still frame at a time. So we need to begin a while loop here, and what we're going to do in it is going to be very simple. We have a graphics window that we call screen. What we need to do is we're going to make comments. We need to update the graphics display for the user to see. And to update the display, meaning if there has been changes to our graphics window, we allow the user to see those changes with the update function, pygame.display.update. Now, updating implies that we have done something to be seen in the update. So before that, inside the while loop, which we're calling the frame loop, we do neat stuff, whatever that is. We do all of our graphics changes. And then we update. And then another comment. We're going to include immediately process the event queue. Processing the event queue means that the code or the computer is going to look into a memory, a buffer, a place in memory for all of the input that the user might have given through the keyboard or the mouse or any other peripheral device while the program was running through the while loop. We have to take a look at the event queue, the possibility that the user has provided input every frame, and then we can choose to react to that input if we wish. But the reason why we have to take a look at it every frame is because problems can happen in the processing of our graphics and animation if there is a backlog of information about user input that is filling up that queue, filling up that memory. So we need to think of it as a pile of work that's happening, and we have to occasionally take a look at that work and respond to it or not in order to empty out our inbox. And if we don't, it might pile up and cause confusion and problems and freeze our program. So the last thing in our frame loop is processing the event queue. And it's going to be, for now, it'll be simple. We'll use a for loop for event in pygame.event.get. So it's going to continually look at all of the events, and an event is an action that the user takes, like pressing a key, releasing a key, moving the mouse, pressing a button, anything, and doing nothing for now. But this part of code needs to do that. This part of the code will empty that memory buffer so that it doesn't freeze up our program. Now we will save and run at this point to check what we've got. We have a graphics window. We can see that the title of the window is stub_0. We can see that our program has started as our printout and idle and is not doing anything but existing, and it hasn't ended yet. If I want to get out of this, I can close it down by Xing. I can also do a Control-C to force a break. Notice breaking didn't get rid of the graphics window because idle is controlling it. So I'm going to X out of idle. This works, but it didn't print end because we never got there. We're inside of a while loop that is continuing to go. It's continuing to update, but there hasn't been any changes, and it's continuing to look for user input, but do nothing but look. So let's do something. We're going to print, and this will be an idle, not as a graphic, the frame number. We have a number that we declare called frame and set it equal to 0. And then after we print it, we'll also increment the frame number by adding 1 to it. This simple change, we'll see that we've got some input or some output. This output is not graphics, it's still using idle, but we can see that the frame number is going up as it's printed. So we can see our while loop processing. Frames are being created, and they're being created quite fast. Okay, we're going to quit out of this by saying if the frame is greater than 1,000, then assign the Boolean that controls the while loop to be false. And we'll run this. You can see the frames go up. Every computer is going to process at a different speed. This computer is a reasonably new desktop, so it's likely to be a little bit faster than most laptops. And we got to the end. We printed end. And the reason why we saw that is because the while loop stopped. There is no more code in our hello function, and so it returned to where hello was called and ran that line and had nothing left to do. Okay, so we got to the point where our window could quit. Our program quit, but our window didn't go away. And the reason is because we are still in the interpreter when our program finished. We can see that again. We do know that our program's going to finish, but then it halts. Idle is still up, and that window is still up. If we wanted everything to be shut down, we could use the quit function. The quit function is a function that tells the operating system to end what is controlling this program. Let's observe the behavior. We're counting up to 1,000 frames, and when we did so, we reassigned our Boolean, but we also quit through the function. And it's asking us if we want to quit. That's the operating system having been given a quit command. And we can say no, and observe that we never got that end printed. So we didn't allow it to quit, but our program did terminate. That's what the quit function does, but I do not recommend using it. You don't need to, it's better if you don't. I recommend not using the quit function because it terminates immediately. The better way to program is to allow your program to finish the way that it is by leaving that loop and getting all the way to the end so that the program has no more lines of code. When you publish a program, it will not, the interpreter and idle will not be necessary to control it. So by ending a program in this way, it will end out of something like idle because idle will not be driving it. Please do not use the quit function. Okay. Our program is not very exciting, but it's a stub, meaning this is what we can begin with so that we don't have to retype everything when we move forward learning other things about graphics and sound and animation. So here is the top of the file to check. And then the bottom of the file to check. And then, of course, the reminder in the now you, if you haven't already, type this with the comments out exactly so that it can be used to move forward in the next lessons.